Hello, my name is Devon. My day job is as an engineer at Adobe. I work on our design system mostly, but also some general front-end tooling. That's me on Twitter. Cool, but today I'm here to talk to you about Parcel, which is a web application bundler. All right, so first I'm going to talk a little bit about why Parcel exists, and then I'll get into what we're doing with Parcel 2. Parcel exists because I was frustrated with developer experience, honestly. I don't know if you've all used other bundlers or other build tools, but it can be pretty frustrating. The main thing was actually slow build times. So I was working on a pretty large application at the time, and it would often take like over a minute to start up the dev server when you wanted to make any development changes. And that was pretty frustrating because anytime you wanted to like restart it or install an npm package or something like that, you gotta like restart it. So I wanted to experiment with trying to parallelize and cache builds. And so at the time, the project was using Browserify. This was years ago. I also tried Webpack and tried to parallelize and cache them, but I quickly realized that their architectures were just not designed to do that sort of thing. And so I started building my own bundler, just kind of as an experiment at the beginning to see what was possible. The other part was the configuration experience. I don't know how many of you have configured Webpack. Not fun. I think it's actually a job title now. Webpack configuration engineer. And the other thing is I wanted to experiment with a more file type agnostic architecture. Most existing tools kind of are focused primarily around JavaScript, and they've kind of shoehorned other types of files into the system later on, which is why you see things like CSS getting inlined into your JavaScript and then extracted later in another build step. Like, that seemed crazy to me. So I wanted to experiment with that as well. So Parcel, I worked on for about 3 months before I released it. It was pretty much built for my uses. I didn't expect anyone else to use it, really. Just put it out there to see what would happen. But to my utter surprise, it was popular. Like, other people wanted a tool that was a little easier to use, it turned out. So now it's been like almost 2 years, and we've got like a big community that's built up around this project, which is pretty cool, and it's been really exciting to follow that. There's like 8 people on the core team now. Like, some of them are work on it full time, which is pretty crazy. Well, so it's been a lot of fun. All right, so let me get into a little bit about what Parcel actually is. So Parcel is a zero configuration tool. You might have heard that term. And it doesn't mean like you can't configure it or anything like that. It just means it's really easy to start. It doesn't require you to configure anything to set up a basic project, right? We have support for lots of file formats out of the box, code splitting, it's fast. We got the caching and workers going, so it'll use all your CPUs when you're compiling, starts up really fast, and we've mainly focused on developer experience. That's like the primary goal with this thing. We want it to be as easy as possible for people to both start new projects and also work on really big projects. Another interesting thing, and I talked about this file type agnostic architecture a little bit, but with Parcel, it's pretty common to start with an HTML file as opposed to a JavaScript. You can start with any file you want, but an HTML file allows you to, it's kind of the natural entry point to your application, right? The browser actually goes to that when it loads, so it makes sense for your build tool to also walk the same hierarchy. So it allows us to do a lot of interesting optimizations later, which I'll get to. Has support for pretty much every file type you can imagine, and there's plugins, so you can have, it supports pretty much everything. All right, So Parcel 2. So as I said, Parcel 1 was pretty much built for what I needed to do. And as it got popular and lots of contributions came in, we realized that it wasn't going to scale to the needs of everyone. So we started designing Parcel 2 like actually pretty soon after Parcel 1 was released, only a few months. And we really worked on it for like almost a year before we even started implementing it. And because we really wanted to get the core right. So Parcel 2 is a complete rewrite of the core. It has an entirely new plugin system with plugins specifically designed for each use case that Bundler does. And I'll go through all of those in a minute. It is optionally configurable. It has everything that Parcel 1 has and more in the default config, but when you need to extend it and override it, you can override and extend pretty much everything that it does. We've improved our core data structures a ton. The Parcel core is actually now incredibly small because everything is a plugin. And so Parcel 2 is basically just a very optimized graph of your entire application. And then that can run various plugins on top of that graph. And we've made it even more scalable for large apps. So it builds really fast, the cache is really fast. Show that in a second. And all the plugins are split out into separate NPM packages as well, which provides really good examples as well, so that people who want to build their own plugins can go look at our packages and copy and paste and modify, which is really important as well. So I talked about the performance. This is a screenshot of Bitbucket. So there's 3 full-time engineers at Atlassian who are working on Parcel 2, which is pretty cool. And recently they got all of Bitbucket building with it. And this screenshot is showing a start from cache. So just starting up the dev server. And there's almost 1 million lines of code in Bitbucket, and it starts in about 2 seconds, which is pretty insane if you've ever tried to build a large application with another tool. This is pretty much just possible because of our cache and our new watcher, which basically allows us to get watch mode performance even when Parcel restarts. Pretty cool. All right, so this is what it looks like. You'll notice it's just JSON, and it's pretty simple and easy to read. You set up these pipelines where you map file types pretty much to plugins, and Parcel will just run through this. Now, this is like a large config showing you pretty much everything, all the plugin types and everything. You have a config at all, which most applications won't need, but if you do, it's probably going to look more like that. You can extend the default config and add additional transforms and other types of plugins in here to do just what you need. All right, so now I'm going to go through all the different types of plugins, and it'll kind of give you a sense of how bundlers work in general as well. So the first thing that a bundler needs to do is actually resolve your code. So it'll take a require call or an import statement or something like import React and turn that into like the path to your project / node module / React / index.js or something like that. So that's what a resolver plugin does. All these things are plugins, so that means you can override and extend all of them as well, which is really powerful. So if you want to add some custom resolution support in your app, you can do it. The next thing is a transformer. So these are things like Babel, TypeScript. Some transformers might transform code from one language to another, and others might transform it between languages or to the same language, Babel. And the other thing that transforms do is extract those dependencies. So they'll parse your code, look for the import statements, require calls, or whatever else is in that language that you're supporting, and generate dependencies for those, which then get sent to resolvers and so on and so forth until you build up a graph of your entire application. So once we've got that graph, that asset graph we call it, it's run through a bundler. So bundler is actually just part of what Parcel does. So this bundler plugin is what takes an asset graph and transforms it into a bundle graph, which means that it groups assets together into the bundles that will be shipped to users. So you might group your JavaScript files together, your CSS files together, etc. And maybe you have some code splitting in there. So that's where all that happens as well. So this is just a graph transform. No actual code is generated here. It's just transforming the graph. Then there's namers. So namers are responsible for choosing the output file names of a bundle. So the default one includes things like content hashed file names for long-term caching and some other things, but you can override it. So maybe you want to have like some sort of directory for your static assets, or you want to like have some other naming scheme, like you can implement it. And there's runtimes. Runtimes are responsible for injecting code into a bundle that can be executed at runtime to do something. So we use these to implement like hot module reloading, implement like lazy loading at runtime. So async import a bundle, then it includes the code to actually do that at runtime. Okay, so we've got all of our bundles. We know what code is going to be in there, but we got to figure out how to actually put them together and write them to disk. So that's what packagers do. Packagers take a bundle and know how to combine all of those pieces of code together that could actually be executed in the browser. So if you have multiple JavaScript files, for example, it knows how to combine them all together, wrap them in functions, do its tree shaking or something like that, and output a JavaScript file. So same for CSS, HTML, all the others. We have optimizers, which are like minifiers or things like that. So cursor or uglify or something, image compression, things like that. Reporters kind of just run throughout. So they are responsible for reporting progress information. So we use them to implement our CLI. It tell you like what's compiling and to give you a nice bundle report at the end. And we have validators too, which let you do some sort of code validation. So this would be like running type checking on your TypeScript code, ESLint, things like that. And the cool thing about these is that they run in the background, so they're not blocking your code from compiling during development, but they'll give you warnings and errors in the console. And in production, they'll actually fail to build. Okay, so that's all the types of plugins. So you can see that it's pretty extensible, and you can override and customize just about anything. So now I'm just going to go through some cool features that we can build on top of this graph. So one is support for multiple targets. So with a lot of other tools, you need to run them multiple times if you want to generate like a modern browser version and a legacy browser version, for example. So with Parcel, you can just configure that in package.json. So here it's specifying that I want a modern browser version that's targeting the last Chrome version, and one that targets all the old browsers. And those will generate more or less code depending on those targets. So like you need to run Babel more for older browsers that don't support modern syntax. And so you'll generally end up with larger bundles that way. Babel generates a lot of extra code that is modern browsers. So this is one way to do it. The other way to do it is if you use an HTML file, you can just do this. So this script type equals module and no module here is a way that browsers support to automatically load the ES module version or the regular script JavaScript version. And the cool thing about this is that browsers that support native ES modules support modern syntax as well. So then file less. So we can do the same thing. So Parcel will pick this up and it'll actually generate two different versions. So it'll rewrite our script tags and generate a module version and a no module version like completely automatically. So you get this basically for free. Just put that in your HTML. Works. We'll be shipping less code to users. The other thing that's cool about ES modules is they support, like browsers support like native dynamic import now, which means that you don't have to include any runtime code to actually load JavaScript bundles at runtime. So another way to make bundles small. This work was sponsored by Chrome, so really cool to see them investing in tooling. So throwing that out there. Other cool stuff you can do. So maybe you have a monorepo. You have a design system with lots of different packages in it, and you want to build all those packages. So instead of writing a custom bash script to go through and compile all the code, just point Parcel at a glob of all your packages like this. So here it's actually pointing at a subset of packages, and it'll go compile all those in parallel for you. So we do this in our design system now. And each package looks something like this. So Parcel actually reads the package.json and determines what the outputs and inputs should be. So source is the input. It's a TypeScript file. And in this case, we have main, which is a common.js version, and a module, which is ES module version, and a TypeScript definition output. And it'll go and compile all those for you across all the packages in your monorepo. And the TypeScript definition thing is also pretty cool. We even tree shake it for you. So we'll remove all of the TypeScript definitions that aren't accessible, or like internal to your package that aren't accessible to the public interface. So we'll just strip all that out for you and generate you a nice small TypeScript definition file, which is something that not even TypeScript supports itself. So did that on top of the TypeScript compiler. So speaking of developer experience, we have recently added really good support for debugging and diagnostics. So here we're showing a TypeScript error. It has like syntax coloring, and you can like usually command click that file name and to open it right in your IDE to that line. We do the same across pretty much every plugin, and it happens automatically. So here's ESLint1, and actually it's showing you multiple errors in the single code frame, so you're not getting like tons of output in your terminal. It's pretty nice too. And we validate things that Parcel reads as well. So if you have configuration in your package JSON that we read, we'll give you hints about how to fix it too. So really trying to focus on making it as easy as possible for people to fix errors they have, not debug like big long stack traces. Okay. So another cool thing that you might want to do is inline bundles into another bundle. This is something that hasn't been that easy before. So maybe I have some critical CSS or JavaScript that I want to get loaded as fast as possible. And so I can write code that looks like this and just import it as if I'm in another file, right? And I can keep this code in a separate file for better maintainability rather than like putting it all in my source HTML. And then Parcel will go and compile that. It'll read our inline script and style tags, and then actually go bundle all of that code and then re-inject it back into the file. So you get your inline code that way. So that's HTML. You can also do this in other places. So we've recently added support for these URL protocols, which let you do inlining and other things I'll get to. So bundle text, this one will compile your CSS file and then inject it into your JavaScript. If you wanted to say put CSS into a data DOM or something like that, which actually requires you to embed it in your CSS. So the cool thing is that it doesn't just take your source file and put it in your JavaScript. It'll actually compile it. So here I'm importing a SAS file, and this will actually be compiled. It'll go through the whole compilation pipeline, optimization pipeline, compile to CSS, and then re-inject it into my JavaScript. Maybe you want to do that with like a web worker or something like that. You can do it. This works for like CSS too. So maybe I want a data URL for this background image. I want to have it be loaded as fast as possible. You can use the data URL protocol to do that, or in JavaScript as well. Now, the cool thing about all of this is it's all implemented outside of core. So Parcel itself doesn't have any knowledge of these protocols. This is all done through what we call named pipelines. So in your configuration, you can create these pipelines that have names. So instead of just matching against a type of file or a glob, you can name them. So I've defined a bundle text and data URL pipeline here, and those just run through some plugins. And so you can create custom workflows by naming pipelines like this and then importing stuff in your code. So the architecture is pretty flexible to allow all this. All right, so a little about future work that we're doing. So with this graph, we have of your entire application, all your assets. We know some things that other tools might not. So we can do things like preload and prefetch assets. So there's these link tags, link rel equals preload and prefetch, which you can use to speed up loading of resources that the browser would normally discover late in the loading process. So maybe you have a background image or a font in this file, and the browser would normally have to like download the CSS and then parse it and then go download the font or the image. So in order to speed up that and prevent that waterfall, you could insert a preload tag into your HTML to load it in parallel with the CSS. And because Parcel has a graph of your whole application, like that automatically. Image optimization. So maybe you have a source image that is pretty big, and we see that in your HTML or your CSS, you have a width set on it. Like we could resize that for you and generate an optimized image. Insert even multiple different resolutions if you wanted. Maybe you have a 1x, 2x, 3x thing going on. We could do that. We're talking with the Chrome team about implementing performance budgets and hints. So performance budgets let you define a limit to the size of your application so that you don't regress performance. We can give you some hints and suggestions about how to improve performance as well. All right, so I have one last thing, and this is just kind of crazy project that I did over the weekend that kind of shows the power of the plugin system and the architecture that we have. So this is using the new React concurrent mode that they just announced at ReactConf. And so the idea here is we have a component or an application on the left, which when you click a button, it shows a random GIF from Jiffy. And so it does this with some code splitting. So when you click the button, it actually re-renders and causes lazy component to render through the normal react.lazy. And then that triggers a query to go fetch the GIF from the Jiffy API, right? And then it finally loads the image. So there's a waterfall here, right? First, when you click the button, first it has to download the code for the lazy bundle. Then it has to go fetch the GIF from Jiffy API, and then it has to actually go download the GIF and render it. So how could we make this better while retaining the nice developer experience of keeping that query in the same file as the component that renders it? So this is actually pretty easy to do with the new Parcel 2. So what we actually want to do is take this create query, the function that's inside create query there, and move it to the parent bundle so that we can call it in parallel with loading the code. So we're loading data in parallel with the code for that bundle. And this actually works. So I don't know if you can see all of that, but there's a waterfall at the bottom, and it shows that the random API is being called in parallel with the lazy code bundle. And that just happens by moving that function from one file into another file. And that's pretty easy to do through the Parcel API. So that's pretty much it. We are coming. There's alphas out now, so you can go try it out. If you want to find out, hear progress updates and stuff, you can follow me on Twitter or Parcel.js. Or you can go to the site, which is parcel2readyyet.com, which shows a graph of our tests passing. But we're actually using the same integration testing suite that we had for Parcel 1, which is super valuable. I'd highly recommend doing that if you ever have to do a rewrite of a project, reuse the tests, because it'll prevent you from progressing. So you can follow that. Thanks.